In this video, I'm going to show you how you can use a Raspberry Pi connected via USB to a DSLR camera and automatically take pictures with the DSLR commanded by Python on the Raspberry Pi. In this tutorial, we'll be using a Canon EOS Rebel T3i connected to a Raspberry Pi Model 2. This will work on different models of Raspberry Pi, and this will work on different models of cameras as long as it's supported with the drivers that I will be showing you in this tutorial. So first things first, you're going to want to have your Raspberry Pi booted up as shown here and an instance of your terminal open as I have shown here. The first thing we're going to have to do is update our Raspberry Pi repositories by typing in sudo apt-get update. This will take a moment. Once that's done, we're going to want to install a few packages. So type in sudo apt-get install, and the first one we're going to install is called gphoto 2. I already have this installed, so that didn't take very long. Next, we're going to want to install with sudo apt-get install python3-pip if you haven't done so already. Finally, we're going to have to download a module for Python 3, so type in sudo pip3 install, and that package will be sh. Next, you're going to want to plug in your camera and power on your camera. So a little bit of background as to how this is going to work. We just installed a package called gphoto 2, and this is a package that allows you to execute bash commands as shown here, or the command is gphoto 2 with options as shown here, and this allows you to take images. Now, not everybody wants to use a bash program, so I'm going to show you how you can import this into Python such that you can write a nice Python script to automatically capture images for you. So we have our camera plugged into the Raspberry Pi and we have it on. Let's try and see if we can see this camera. So type in gphoto 2 auto detect and your camera should show up here. If it doesn't, you're going to have a problem. Just make sure that your camera is compatible with the gphoto 2 drivers here. So great, let's just get started and see if we can take a picture. So type in gphoto 2 trigger capture. And you'll see that you encounter this error, and this will happen every time you try to connect your camera to your Raspberry Pi and turn it on, or every time you reboot the Raspberry Pi. Why is that? That's because if you type in the command ps-a, it will list the processes that are currently running, and we see that a gphoto 2 process is already running. We're going to want to kill this, so in this case it has PID 5520, so we're going to kill 5520, list the currently running processes, and we see that there's no gphoto process. So now if we try to trigger our capture, we see that it works, and there we have it. So as I said, that process will pop up every time your camera gets turned on and connected, and it's a little tedious killing it by hand every time. So in the Python script, I'll show you how to do that automatically. So we've captured our pictures. Here, let's just do it again. So gphoto 2 trigger capture. We've captured our pictures, and let's take a look what we have on the camera by typing in gphoto 2 list files. And here we see there are no files stored anywhere on the SD card of the camera. And the reason for that is by default, gphoto 2 will set up your camera such that whenever it captures an image, it saves it to the internal RAM of the camera rather than the SD card. So let's change that. Type in gphoto 2 get config, and what are we going to get the configuration of? We're going to get the configuration of our capture target, one word. Here we see that we are currently capturing and saving our images to the internal RAM, but we can also change it to option 1, that is the memory card. So type in gphoto 2 set config capture target equals 1. And now, if we run the get config of the capture target again, we see that we've now switched it from the internal RAM to the memory card. Now if we try to capture an image, trigger capture, and we try to list the files that we have on our camera, we see that we actually have two files here, the RAW and the JPEG, and this is a setting that you can set on a Canon camera to acquire both the RAW and compress it to the JPEG format. This is the most complicated setup that you can have for image acquisition, and that's why I'm using this for this particular tutorial. Moving right along, we see we're in the root directory of the Pi here. I'm going to navigate to the desktop and we see, okay, we have some folders here. Let's create a new folder called gphoto and navigate into that folder. Okay, so let's work on downloading the images automatically. So we have list files. We have files on our camera, and to download these, you're going to type in gphoto2 -- get - all - files. And here we see we now have 2 files inside of our gphoto directory. On the desktop, if we go to the gphoto folder here and open up that JPEG, we see we do actually have a picture here that the camera took of my Raspberry Pi leaning against my modem. Not a particularly interesting picture, but it's going to work for the purposes of this tutorial. Let's say our SD card is full. How do we go about clearing the images off the SD card? Well, one would think that if you typed in gphoto2 delete - all - files, that would take care of it. And if we list the files again on the SD card, we see that they're still here. And the reason for that is because the delete all files command is actually trying to delete the files in the root directory, whereas what we're really trying to do is delete the files in this directory, which is unique potentially to my Canon camera. So you have to check to make sure that the directory your files are saved in is the same as this one here, or you're going to have to adjust it for your own purposes. To deal with this, you're going to have to type in gphoto2 -- folder equals quotation, and then you have to type in the directory that you want to, that your pictures are being saved to. And you're going to want to delete all files. Double dash though in front of delete all files. And now when we try to list our files, we see that yes, there are no longer any files saved to the SD card. Perfect. That shows us all the commands that we're going to need to know to be able to capture pictures with our DSLR. We know how to trigger the capture, save the files to our Raspberry Pi, and clear the images off of our camera. Now all we have to do is get this running in a Python script for ease of use. So let's go ahead and get that started. So navigating back to our Raspberry Pi desktop here, we're going to want to open up an instance of idle 3. I'm going to be writing this script for Python 3. If you want to use Python 2, you may have to modify the script, and you may have to download packages for Python 2 instead of Python 3. We're going to create a new file. We're going to save this file as, let's go to desktop, gphoto, and we're going to save this file as image capture.py. Excellent. So first things first, we're going to have to get some packages imported here. So from time, we're going to import sleep. From datetime, we're going to import datetime. From sh, we're going to import gphoto2 as gp. This will allow us to use the command gp as if it were a function in Python, which really means we're going to be using the gphoto2 program. We're also going to want to import signal, OS, and subprocess. Okay, so remember, whenever we connect our camera, we're going to want to kill the gphoto2 process that starts whenever we connect the camera. So how did we do that? Well, here, let me turn on cycle power on my camera again, so I'm just going to turn it back on. And we're going to go back to our terminal here, and we type in ps-a, and we see that gphoto2 shows up here, and we need to kill that. And the PID changes every time the process changes. I mean, it just keeps on incrementing this number here. So we can't just keep killing the same PID. We're going to have to look up in this list output of ps-a, we're going to look up for this identifier, which is what we just used to find out what PID we had to kill. So following that same logic, and this here, this is the reason why gphoto keeps popping up, is because this pops up, and that's the process that happens. So to kill the gphoto process, we're going to create a function called kill gphoto2 process. And we'll just call this function every time we need to kill it. So first, we're going to, using subprocess, we're going to open up that command pretty much. That command being ps, And we're passing in, and let me get the mouse out of the way, we're passing in the option of -A. So when you want to execute a command in like bash and with an option, you need to pass it in like this shown here. And then std out is equal to subprocess dot pipe, pipe being capitalized. And then we're going to get an output from that when we communicate with our new variable p that we created here. So now we have our output. So we're going to search for the line that has the process we want to kill. And so for the line in the splitting of out into subsequent lines, we're going to be looking for, and because we're working in Python 3, we need the byte value of the identifier, which is GVFSD-gphoto2. So we're looking for this value in the line. And if we find that value, we want to kill the process. So if we find that value, we're going to get a PID value, and that value is an integer of splitting up that line that we have there. We want the first column, and so we look for that column and we save it to the PID that we want to kill. So now we have our PID. So using OS, we're going to pass in the PID that we want to kill, and we're going to the signal.signal here, or signal.sig kill here. All right, so that should kill the process. Next, we're going to, if we're doing time-lapse photography, which I assume most of you are going to want to do, because why else would you want to automatically control a camera, aside from like machine vision or something like that? If we're going to... Oh, if I lose power, I'll be very upset. There's quite the thunderstorm going on right now. So anyways, if we want to do time-lapse photography, it's really good to keep track of the date and time when pictures are taken. So I'm going to create a value here, shot_date, and we're going to use datetime, one of the modules we imported, get the current time, and we're going to format the string output of the now as year-%month-%day. And we're also going to take a shot time, and this will include the date time. This will include the date as well as the time. So we're just going to string format that time again. We're going to pass in year-month-day, and we're also going to get the hour-minute, second. Excellent. So now we have the date, and then we have the date and time as two different values. And then we might want an identifier, just so that we can keep track of what it is we're taking pictures of. In this case, it's pictures of my Pi, so that will be Pi shots. I mean, you can change that to whatever you want. Okay, so now we know how we're going to structure, how we're going to save our images. Now we need to execute the commands, the gphoto2 commands, to take pictures with our camera. So the first command that we did is to download our photos, we want to make sure that we don't have any files on our camera. Like, we'll clear away the old files so we don't fill up the SD card on the camera. And so we're going to need a command to be able to clear the files. And remember, when we clear our files, so I'm just gphoto2 --list--files. Oh, so we can't run it because we have that process, so let's kill the process. So we're going to kill 5781, and then I'm going to list the files on the camera. Remember, we are saving files in this directory, so when we want to delete the files, we want to delete the files in that directory there. So clear command is going to be specifying that folder with an F. And then, because it's an option, we need to specify the directory that we want to clear. So in this case, it's store_302301/DCIM/100 Canon, and this will vary depending on the camera that you're using. And then we're also going to want to make sure we get rid of all the files in the directory. And finally, the command that we used is delete all files. Excellent. So in addition to clearing the SD card, something else we did was execute a trigger command. So we're creating a value here called trigger command, and that will just simply be --trigger-capture. Following that, we executed a download command. So we're going to create a value here, download command, and that's going to be equal to -- get all files. So the idea is we start up, we clear what's on the camera, we take a picture, we download the picture, and then we clear those pictures from the SD card. So we're going to also want to save these files to a folder. So the folder name will be a combination of the date, so shot date, and the identifier that we had created earlier. We're going to automatically create this folder because let's say we're doing time-lapse over multiple days. We're going to want to create that folder for multiple days to keep track of what's going on. So going back here, let me just clean this up. We're in the gphoto directory, but we're going to create a new directory called images. So we now have this images directory that we can navigate to, and so our present working directory is home pi desktop gphoto/images. We're going to use this directory as our save location. home/pi/desktop/gphoto/images plus the folder name, and we're going to create. So to be able to create that folder using the script, we're going to create a function here called create save folder. And what we're going to try to do is make that folder. Make the directory save location. And let's say we have already taken pictures today. In that case, we would have already created that folder and wouldn't be able to create a new one. So in that case, that's why we're using the try except, is otherwise we're going to fail to create the new directory because we're only going to be able to create that directory once with that unique name, right? Then we're going to change our present working directory of our Python script to that save location so that we can save files in that directory. Next, we're going to need a function to actually capture the images. So I'm going to create a function here called capture images. The thing we're going to want to do is run the trigger command. That means we're actually executing the command gphoto2 trigger capture. Now the thing is with the command trigger capture is that it doesn't wait for the camera to be ready. When you execute the trigger command, it triggers the camera and then it will trigger the camera again if you tell it to, even if it hasn't saved the contents of the capture. So it's important when you're doing things like long exposures. Let's say you're taking a picture of the stars and you have your exposure settings to be quite long. If you space the trigger capture too close together, you're not going to be able to save it to the SD card and you're going to start having some problems. So this is the reason why we include a sleep here, is such that we can sleep between our trigger captures. Before we start to try to download the images off the SD card. Once we have the images downloaded, we can clear them off the SD card with our clear command. Now there is an alternative to trigger capture, and that is image capture. With trigger capture, you have to worry about how long you sleep after sending the trigger command, and with image capture you do not. However, it is a slower method of taking pictures, and trigger command is generally faster if you know what you're doing. Alright, so we have created a save folder and we have created a function to capture the images and download them to that save folder. However, we are at the mercy of the camera's indexing. Remember how the camera indexes images using img_number.jpg or something like that? We're going to want to create a new function now where we rename the files that we download into something that makes sense for our time-lapse photography. So what we're going to do is we're going to create a new function here called rename files, into which we pass our ID for those pictures. Remember, we're taking pictures of both JPEG and RAW file format. So we're going to have to name those individually, and the way that you go about doing that is first we're going to have to take a look at the files inside of our present working directory, and we're files in that directory that have a long name to them, because when we take a picture it was named something like img_4numbers.jpg for a total of 12 characters. So if our name is under 13 characters, that means we haven't named it the convention using the year, month, day, hour, minute, second notation that we have up here. So of the files that are under 13 characters long, we're going to look for a file name that ends with the JPEG extension. This way we can differentiate it from our RAW file format. So type in os.rename, and we're going to rename that file name with the shot time and the picture ID from the function, plus the ending .jpg. Print renamed the the JPEG. All right, so if it's not the JPEG, then the file name will be ends with .cr2, and this is a Canon ending. You might not have this being saved at all, depending on how you have your camera set up, or it might be a different ending. So it's more or less the same line of code. We're just looking for the CR2 ending here. And we're going to rename it with the CR2 ending, and then we're going to print renamed the CR2. That way we know things are kind of working here, and that's more or less it. So we have our functions here. The first thing we need to do is, what did I call it? Kill gphoto2 process. So the first thing we're going to want to do is kill the gphoto2 process, and then we're going to want to clear the SD card. So I called that command clear command. And then we're going to want to create our save folder into which we'll save our files. And then we're going to want to capture our images. And then finally, we're going to want to rename our files, and we need to pass in an ID, and I call my ID pic ID. And I mean, you can change that for however you want. Let's give this a save, and let's try running it and find out where all my typos are. So, navigating to the gphoto directory. Here, let's clean that up. Navigating to the gphoto directory, we type in python3 image capture.py. Remember to turn on your camera before you hit enter. So it sounded like we took our pictures, and it looks like we renamed our JPEG and CR2. Let's validate that. So gphoto, images. Here we have a new folder that we didn't have before. Today is the 13th of August. And in here we have two files named with a date and time and our subject, .jpeg, we'll take a look at that one, and our RAW file. Wow, I wrote all that with no typos, eh? Isn't that cool? So anyways, there you have it. So that was only one instance, not terribly useful if you're trying to do time-lapse. Or rather, let's prove that the killing of the process works. So here, I'm going to cycle the power on my camera. So it's off now. And I'm going to turn it back on. Look at the processes that are currently running, and we see gphoto2 is running. So we've cycled the power. Let's try taking pictures again. And here we see that we failed to create a new directory, and that's because we already have that directory made for the day. We rename the files, but it's running when we cycle the power on the camera. Therefore, we know that that kill gphoto2 process up here is working. Here on out, it's pretty straightforward. We can just we start up the script, so we kill any process that's running, and then we clear the SD card. And then we're going to go into a while true loop, which will keep on running infinitely. We will create our save folder and capture our images, and then we will rename the files, and then finally we're going to sleep for a bit, and this is going to be the amount of time that you want for your time lapse. So let's give this a run. Directory, we try to execute image capture.py. So we take our images, we sleep for a couple of seconds, let the camera do its thing, we download the files, we rename the files, we then sleep for 5 seconds, and we keep on going over the process here. So every 5 seconds, the Raspberry Pi will automatically trigger the camera to take another picture. It will download the files to the Raspberry Pi or an external hard drive if you have that configured, and won't stop until we keyboard interrupt the script. Oh, that is not what I wanted. There we go, keyboard interrupt. So there we have it. A digital SLR being controlled by a Raspberry Pi and having the images automatically saved to the Raspberry Pi as if it was time-lapse photography. I hope you enjoyed this tutorial.